Chemistry 2016 Examinations, Paper 1, Question 8. Give it a try, then hit play. So this one's looking at different periodic trends, which means I need to think about what these different trends mean. Atomic radius means how far out the electrons are from the nucleus. Ionic radius means that once I have lost or gained an electron, how far are the electrons out, or the outermost electrons away from the nucleus. First ionization energy is how much energy it takes to remove an electron. And electronegativity is the amount of energy one atom has to pull an electron that is shared between two atoms to itself. So we need to have those four things in mind. Now we need to think about the trends and which of these combinations is correct. So it's asking us atomic radius as we go down the group. So from top to the bottom, what's happening to the atomic radius? Well, it's got to increase, because as we talked about in the last example, as we are going down, we're increasing energy levels, which means that I'm getting further from the nucleus. So we've got an increase in the radius, the atomic radius. We'll do an A here. And then as we're going across, the atomic radius actually decreases. Decreasing the atomic radius, and that is because even though I'm adding more electrons and protons, those more electrons and protons are going to pull each other more. It's kind of like having a bigger magnet as you go across, as you're adding them. They're going to pull each other more, and so it actually gets smaller as you go left to right, even though it's getting more massive. So the mass is more, but the size, the distance between the nucleus and the outermost electron, is actually decreasing. So A is not our correct answer. We talked about ionic radius, but we talked about it with relation to what's happening with an atom and its ion. That's where we spent the most of our time. So we're going to move on. We're going to start in the opposite directions and talk about electronegativity, which again is the amount of pull that one species has on shared electrons between two species. The most electronegative atom that we have is fluorine, and the least is francium, and that can help us in determining what's going on. So francium, with its really big radius, is not holding on to its outermost electron very well, so it takes very little energy to, or it holds things much less. Like the nucleus is not holding the electron very well. So the atomic, or the electron configuration is going to be the electronegativity, the electronegativity value actually decreases. I'm going to do E-neg for short. We're decreasing the electronegativity. That francium can barely hold on to its own electrons, so it's not going to have a good hold on other electrons. So it's decreasing as we go down, and we would be increasing as we go across, because we're getting closer to that fluorine. Those halogens only need one more electron to be like the noble gases, so they're going to have a strong pull on any shared electrons. So it would increase the electronegativity, which means D is the correct answer.